Welcome to a lesson on exercise 9G, simultaneous equations using elimination. So as I've mentioned in the previous couple of lessons, there are a few ways to solve simultaneous equations, which is really just when you have two straight lines to find the intersection point between them, to find the point where the two straight lines meet. That's really what we're doing. And so look, we've done the graphical method, then we used substitution, and today we're doing the final way to solve simultaneous equations, which is elimination. Now, the broad concept for this particular method is as follows. If you have one, let's say you have 1 plus 2 equals to 3. And you also have another equation, and you know what, I'm just going to make something up. 2 plus 1. Actually, let's make it 4 minus 1 equals to 3. Now, we know that both of these equations are true. We know both of those equations are true. And the idea is, when you have two statements which are true, you can actually add them or you can subtract them, and you will get a third statement which is also true. So for example, I know 1 plus 2 equals to 3, and I know 4 minus 1 equals to 3. We have two true statements. These statements are absolutely true. There's nothing wrong with them. Okay, we can add these up if we chose to, if we wanted to. We could say, you know, let's add these up. And 3 plus 3 is 6. And over here, we're adding it up. 2 plus negative 1 gives me 1, which will be positive. And then 1 plus 4 is 5. So as you can see, 5 plus 1 does give me 6. I've simply added up every single term, so to speak. And you're allowed to do that, it turns out. You actually get an equivalent statement. And that's the concept, okay? The concept is you can add or subtract two statements if you know both of those statements are true. If you know both of those statements are true. So let me give you an example of subtraction now. So for example, if you had, let's say 2 plus 1 equals to 3, and you had 4 plus 5 equals to 9. And just, you know what, actually, I'm going to leave it like this. And let's subtract the two statements. I'm now going to be subtracting them. 3 minus 9 gives me minus 6, okay? So we're subtracting them. So I'm going to write it over there. 3 minus 9 is negative 6. 1 minus 5 is minus 4. 2 minus 4. So 2 minus 4 is negative 2. And negative 2 minus 4 actually does give me negative 6. So you can actually subtract two equivalent statements, and you can add equivalent statements. Not equivalent, sorry, two statements which are true. Okay, so you can add and subtract statements as long as the original statements, the ones that you're adding and subtracting, as long as they are true. And now we can use this in simultaneous equations to help us eliminate a variable. So observe, if you had this, you could actually, it says add equation 1 to equation 2. We can add these up. We can also subtract them, but first I'm going to try and add them together. So let's see, let's try adding them together. 10 plus 2, 12. Okay, plus 2y minus 2y. If you add these together, you get 0. And x plus x gives you 2x. 2x plus 0. We don't really have to write the plus 0. It doesn't really contribute anything. And therefore, x is equal to 6. Because you divide both sides. You divide every term on both sides by 2 to give us x equals 6. Now that you know what x equals to, you can sub it back into either of those two original equations to get our y value. So if we have 6 plus 2y equals to 10, and we're just going to solve this now. So that's just 6 plus 2y. Expanding doesn't really change anything. I'm going to subtract negative 6. I'm going to subtract 6 from both sides. So minus 6 there, minus 6 there, leaving me with 2y equals to 4. Divide every term on both sides by 2, leaving me with y equals to 2. So that's my solution. X equals to 6, Y equals to 2. And yeah, so this is a third way, a third method of solving simultaneous equations. You can add equations together or you can subtract them in order to eliminate a variable, so in order to get rid of one variable. Let's have another look. Determine the point of intersection of the lines x plus y equals to 6. Let's write this down. X plus y equals to 6. All right, that doesn't work. So x here, x plus y equals 6. And we have 3x plus y equals to 10. Now, a bit of a hint, you do want to write... Sorry, I seem to be losing my voice. So you do want to write, the x's on top of one another, like, you know, in a line, and you want to write the y's in a line, and any common, any constants, any numbers, you want to write in a line as well. You don't want to write like this, x plus y equals to 6, and then write y plus 3x equals to 10. Not that there's anything wrong with it, but it's just a recipe for disaster. Just don't do it. Write it the way I've written it. So x is on top of one another, y is on top of one another, you know, in a row, in a column. And yeah, so don't do this. Don't do this. Bad. Now over here, we can use addition, or we can use actually we're gonna have to use subtraction here. So let's subtract the top equation, bottom equation. Let's subtract them. Okay. So we're gonna do the top minus the bottom. 6 minus 10 gives you minus 4. The equal sign comes down. Y minus y gives me 0. That's why I'm subtracting them, because I wanted to get rid of the y. So the plus, right? Plus 0, right? X minus 3x gives me negative 2x. You just have to be careful that you subtract it properly. Top minus the bottom. X minus 3x. It's different. See, 3x minus x is different to x minus 3x. It's not like addition. In addition, you can do 1 plus 2, or you can do 2 plus 1. You get the same answer. But in subtraction and division, the order in which you do it actually makes a big difference, because 2 minus 1 is equal to 1, but 1 minus 2 is equal to negative 1. See, different answers. Whereas over here, in addition and multiplication, it doesn't matter which order you do it. You're going to get the same answer. Anyway, so that's why we have to be very careful when we're doing this method. You have negative 2x is equal to negative 4. I'm going to divide every term on both sides by negative 2. So divide this by negative 2, divide that by negative 2, and you're left with x is equal to, and by the way, plus 0, you don't really have to worry about. So yeah, negative 4 divided by negative 2, giving you just 2. Now that you know what your x is equal to, we can certainly substitute it back into either of our original equations to find the value of y. So let's do that. We know x is equal to 2. So I'm going to sub this back in to x plus y equals to 6. You could have chosen the other one if you want, doesn't matter. But I'm choosing this one because it seems to be simpler. Now I know x is 2, so I'm going to sub in 2 plus y equals to 6. And then I'm going to subtract negative 2. I'm going to subtract 2 from both sides, leaving with y equals to 4. So that's my solution. Now, I do want to answer the question in such a way that, you know, it says determine the point of intersection. And so I have to write down, like, the point of intersection is 2, 4. The 2 comes from the x value, and the y comes from the y coordinate, right? That's how you find the point of intersection. Let's look at another question. This is a harder one. So you might have something like 3x plus 2y equals to 6. And you have 5x plus 3y equals to 11. And this is a harder one. Now, when you have something like this, what you want to do is, now remember, anytime you have an equation, you're allowed to do 4 basic operations. You can subtract a number as long as you subtract it from both sides. You can add a number, any number, as long as you add it to both sides. You can multiply by a number as long as you multiply every term on both sides by that number. Okay, That's the key here. You can multiply an equation as long as you multiply every term on both sides. That is so key. You need to understand. Now over here, I can't really subtract anything. See, the idea is when we add or subtract in the method that we're doing today, when we add or subtract, you want to get rid of a letter. So over here, when you had this, right, I subtracted because I knew y minus y would give me 0. That's why I subtracted. In this question, I knew if I added 2 plus 2y plus negative 2y, if you add these together, I know it's going to be 0 and the y will disappear. That's why I added them. I could have chosen to subtract because then I know x's would have disappeared. So it's up to you, really, what you want to do, right? Now, however, the problem in this question is I can add or subtract and a letter will not disappear. As you can see, if I add everything up, I'm going to get 8x plus 5y, which doesn't really solve the issue because I still have x's and y's. I want to get rid of a letter because you cannot solve. You can't. It's impossible. There's an infinite number of solutions. If you tried to solve this, you would have an infinite number of solutions. There's no one solution. You can't solve that. And the only way to solve an equation is if you have one variable, one equation. So if you had 3x plus, 71 is equal to 52, because you only have one letter, you can solve that. As soon as you have 2 letters or more, so you have 2 variables or more, you can't. You need to use a trick of some sort. And not a trick, but like, a technique, a mathematical method. And which is what we're trying to learn, right? We're trying to learn simultaneous equations. When you do have 2 variables, you need to have 2 equations. Okay, that's another rule. If you have 1 variable, you need 1 equation to solve it. If you have 2 variables, you're gonna need 2 equations to solve. I don't want to make it too complicated, but let's just stick to the question. Over here, we cannot add the equations together and eliminate a variable. So we're not really going to add. You also can't subtract and eliminate a variable. So we really can't subtract either. So what you want to do over here in this case is you want to multiply the top equation and the bottom equation in such a way that you will then be able to add or subtract the equations. Okay. So for example, if I multiply, I'm looking at the y's at the moment, right? 2y and 3y. If I multiplied every term on both sides of the top equation by 3, if I did 3 times that, and the bottom of it, I did 2 times this, then notice that the y's will become the same, right? 3 times 2y is 6y, 2 times 3y is 6y. I will then be able to subtract them. Okay, if I have 6y and 6y, and I subtract these, 6y minus 6y, I'm going to get 0. Which is what I want. I will eliminate all the y's. I'll get rid of the y's. Then I'll have the x's left only, and I can solve that very easily. Okay, so that's my plan of action. I'm going to multiply every term on both sides of the top equation by 3. And I'm going to multiply every term on both sides of the bottom equation by 2. Because I want 6 y's at the end. So let's see what happens. I'm going to convert both of these into a new form. So I'm going to get 3 times 3x, which is 9x. 3 times 2y, which is 6y, is equal to 3 times 6, which is 18. Remember, this is one of our fundamental rules. You're allowed to multiply every term on both sides by the same number. It doesn't change the equation. And the bottom one, I'm going to multiply every term on both sides by 2. So 2 times 5x, 10x. 2 times 3y, 6y is equal to 2 times 11, which is 22. Okay, now I can see that I have 6y and 6y. I can subtract these. Let's subtract these, right? And the y's will disappear. So 18 minus 22 is negative 4. 6y minus 6y is plus 0y, which you don't have to write because plus 0 is nothing. And you have 9x minus 10x, right? 9 minus 10 gives you negative x. And we should be able to solve this fairly easily. I'm going to multiply every term on both sides by -1. I mean, there's many ways to think of this. I like to multiply by -1 to flip the sign, right? Negative x times -1 gives you just x, and that gives you just 4. And I'm done. X is equal to 4. Well, I'm not done because I still have to find y. So let's do that now. Wipe that stuff off. And let's come back to the top here. Now we know 3x plus 2y equals to 6. You can choose either of them. I've chosen to do this one. Doesn't really matter. So I do 3. And what's x? X is 4. I've just figured out that x is 4. So I'm going to put 4 there in brackets. Plus 2y equals to 6. And let's solve this. 3 times 4 is 12. Plus 2y equals 6. Subtract 12 from both sides. You get 2y equals 6 minus 12 is -6. Divide every term on both sides by 2. And after y is equal to -6 divided by 2, which is -3. And so that's my solution. X equals to 4, y equals to 3, or another way to think of it is 4, -3. And I've solved it. So this is about as hard as it will get. Even if, in year 10, I don't think it gets much harder than this. This is about as challenging as it will get. Look, simultaneous equations is definitely in the yearly exam. I'm telling you now, I've made the exam and I'm telling you it's in it. But I haven't chosen a question as hard as this. Okay, not a question like this. But you should definitely know how to do something like the first 2 examples I showed. Okay, simple subtraction of equations, simple addition of equations to solve simultaneously, and the method we learned on Monday. It's definitely in it. One of those 2 methods is definitely in it. Not a question as hard as this. Okay, but you should learn. I don't think it's particularly hard. It's just one extra step, multiplying equations. But yeah, I'm just saying. So please make sure you pay attention to it. It's definitely in the yearly exam, and it's worth multiple marks. All right, anyway, let's move on to a word problem. Kathy is older than Blake. The sum of their ages is 17 years, and the difference is 5. Find Kathy and Blake's age. Okay, so the age of Kathy, I'm going to call this X. That's Kathy's age. And Blake's age, I'm going to call Y. So the sum of their equations is 17. X plus Y is 17. All right. And the difference is 5 years. Now, Kathy is older than Blake. So X minus Y. Kathy's older. X is older. X is more. I'm going to put it first. X minus Y is going to give me 5. Okay. And now we can solve simultaneously using the techniques we have learned this period. Now I know I can do addition or I can do subtraction. Both will work here. And the reason for that is if I add, then plus Y and the negative Y will cancel out and I'll be left with just X. If I subtract, then X minus X will cancel out and I'll be left with just the Y's. So you can do either. I'm going to do subtraction this time because why not? And I also want to show you something. So if I subtract these two, X minus X just gives me 0. I don't have to write it. Plus Y. Now notice you have plus Y minus, we're subtracting, right? That's why there's a minus, we're subtracting. But what are we actually taking away? We're taking away negative Y. There's a negative Y there. Okay, you have to be very careful. So make sure you're paying attention. You have to be very careful when you're subtracting. When you're subtracting 2 equations, you have to be very careful, especially if the bottom number is a negative as well, because you're gonna have to end up adding Y plus Y, because if you expand that bracket, you get Y plus Y. And so it's going to be 2Y here, which is very unintuitive if you are not confident in your algebra, I guess. And then we are subtracting 17 minus 5 is 12. Okay, and I've eliminated X's. Now I can solve this as per normal. So I'm going to divide every term on both sides by 2, giving me Y equals to 6. And now I'm going to sub this back into either of those 2 equations. Let's choose X minus Y equals to 5. chosen at random completely. I know y is 6, so x minus, and I'm going to put it in brackets, 6 is equal to 5. Now that's a minus 6, so I'm going to add 6 on both sides. Add 6 on both sides, giving me x is equal to 11. And so x is 11. X was Kathy's age. Kathy is 11 years old. What about Blake? Well, if Kathy, the difference in their ages is 5 years, so Blake must be 6 years old. And look, you can, oh, actually, we've already done that. Yeah, y 6, x is equal to 11. So yeah, we've already done it. Even if you didn't, as soon as you found y is 6, we found Blake was 6 years old. We know the difference is 5 and Kathy's older. You can reduce x is 11 without really doing the algebra. But anyway, it does work out. Everything worked out. Let's have a look at the last question for today, which is John purchases 3 daffodils and 5 petunias from the local nursery, and the cost is $25. Julia buys 4 daffodils and 3 petunias, and the cost is $26. Determine the cost of each type of flower. Okay, so the cost of daffodils, I'm going to call X, the cost of daffodils. And the cost of petunias, I'm going to call Y. Okay, it's very important that you don't say, I'm going to call petunias 5. Petunias, you don't say that I'm going to call petunias P or Y. No, it's the cost of petunias. It's a very important distinction. We've purchased 3 daffodils, right? I know you're purchasing 3 daffodils, 3D or X. I've chosen to call it X. That's the cost. Plus 5, and the cost of petunias is Y. And it cost me $25. Let's make my second equation. Julia buys 4 daffodils. So 4X plus 3Y is equal to 26. Should we just double check that? 3 daffodils, 5 petunias, 4 daffodils, and 3 petunias. Yeah, seems to be right. Determine the cost of each type of flower. So let's solve this. Now, this is one of the, this is one of the harder examples because you can't straightforward eliminate something. If I add these together, nothing gets eliminated. If I subtract these, nothing gets eliminated. So I'm going to have to multiply these equations to make the numbers the same. So what can I multiply top and bottom by such that either the y's will have the same coefficient or the x's will have the same coefficient? And so really what we're looking for is we're looking at the least common multiple. And for 3 and 5, it's going to be 15. If I can multiply this bottom by 5, it's going to become 15. If I multiply top by 3, it'll become 15. And so I can certainly do that. I can do multiply this by 3 and multiply that by 5. Okay, to make the coefficients of y 15. And then I'll be able to subtract it and yada, yada, yada. Alternatively, another way to do it, and they're completely equivalent. You can use anything you want. It doesn't really matter. Another thing you can do is let's make the coefficient of the x's the same. So what's the least common multiple of 3 and 4? 12. So if I multiply the top by 4, I will get 12x. If I multiply the bottom by 3, I will get 12x. And you can do that as well and subtract and yada, yada, yada. The x's will disappear. Okay, so you can do either. You can do times 3 times 5. You can do times 4 times 3. The idea is you want to then be able to subtract or add the equations so that one of the variables disappears. So look, eeny, meeny, miny, mo, whatever. I'm just going to choose the right one. I'm going to multiply by 3 and multiply by 5. You get the same answer. Let's just multiply by 3 and 5. Let's multiply top by 3. So I'm going to rewrite the equation. So I have 9x. And all I'm doing now is I'm multiplying 3 every single term by 3. I'm multiplying every single term by 3. 3x times 3, 9x. 5y times 3, 15y. 25 times 3, 75. Now, in the second one, I'm going to multiply every term by 5. So 20x plus 3 times 5 gives me 15y is equal to 5 times 26. Should be 131, but I'm just going to double check because I'm not really sure. 131 sounds a bit wrong. 26 times, and we are multiplying by 5. It's 130, yeah. So it is 130. 130. It was not 131, it was 130. Anyway, now I can subtract them. So I can subtract top from the bottom. So let's do that. If I do 15 minus 15y, you get 0. So that variable will get eliminated. 9 minus 20x is going to be negative 11x. And over here, 75 minus 130, 25 plus 30, 55. Negative 55. Okay. And all I've done over there is I've counted up from 75 to 100, which is 25. And then from 100 to 30 is 30. And that's just 55. So a bit of mental maths. We can just divide both sides. Sorry, we can divide every term on both sides by negative 11. And you get Lx is equal to negative 55 divided by negative 11 should give me 5. So I found my x. Now I just substitute back into any of the original equations. Sorry. And I will get y. So I can sub back into either of my original equations. Let's choose the second one this time. Why not? 4 and x is 5. We found out x is 5, so I'm going to sub in 5 for it. Plus 3y equals 26. So 20 plus 3y equals 26. And then you have 6 on this side because you subtract 20 on both sides. You divide both sides by 3, and you end up with y equals to 2. Those are my two equations. And let's interpret it back. It is a word problem. Anytime you have a word problem, you always want to give your answer in as a word, okay? So determine the cost of each flower. Now, what was y? Y was the cost of petunias. And petunias are clearly $2. Petunias are $2 each. And daffodils, which was X, daffodils are, and they're $5 each. So $5 each. And look, we can certainly check our solution as well, $5 and $2. So John purchased 3 daffodils and they're $5 each, so $15. And 5 petunias, which are $2 each. So 5 times 2 is 10. That's $25. 15 plus 10, $25. And Julia buys 4 daffodils. And daffodils, remember, are $5 each. Daffodils are $5 each. So 4 times 5 is 20. That's 20. And the 3 petunias, remember, petunias are $2 each. 3 petunias means $6. And the total cost is 26. So yes, we have solved it correctly. Our answer meets both of those criteria. And we've checked it. And we know we got it right. So yes, I believe that is it for today. So best of luck with your homework. I'm going to be here till the end of the period to help with anything you don't understand. More than happy to do more examples or to explain anything. Please do let me know. I'm stopping the YouTube video here.